Welcome back to the channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you'd like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam MFE. Assume the Black-Scholes framework. Consider two non-dividend paying stocks whose time t prices are denoted by S1 of t and S2 of t, respectively. You are given that S1 of 0, so the price of the first one at time 0 is 10, S2 of 0, so the price at time 0 for the second stock is 20. Stock 1's volatility is 0.18. Stock 2's volatility is 0.25. The correlation between the continuously compounded returns of the two stocks is negative 0.40. The continuously compounded risk-free interest rate is 5%. A one-year European option with payoff equal to the maximum of the minimum of 2S1 of 1 and S2 of 1 and minus 17 and 0 has a current time 0 price of 1.632. Consider a European option that gives its holder the right to sell either 2 shares of stock 1 or 1 share of stock 2 at the price of 17 1 year from now. Calculate the current time 0 price of this option. Let us write X for the price of the option in question. The item that we asked to calculate is the price of the option specified. The payoff of the option whose price we are asked to calculate is the maximum of 17 minus the minimum of 2S1 of 1 and S2 of 1 and 0. And this is basically the payoff of 17 strikes put on a minimum of 2S1 of 1 and S2 of 1. So let's define a new asset, which is the minimum of 2S1 of t and S2 of t, the value of it at time t. It's a new asset that we will try to work on. And we will consider not just this new asset, but also a European call and put on it. The option whose price is given in part 6 of the question as 1.632 is a call on this new asset with a strike price of 17. The option whose price we are calculating is a put on that asset with otherwise the same characteristics, strike price, expiration date, etc., as the one whose price we have as 1.632. We can then write the put call parity for these two options on this newly designed asset. Price of a call minus price of a put is prepaid forward price of the newly defined asset minus present value of exercise price. And this M of t is the minimum of 2S1 of t and S2 of t. Well, that's the same as 2S1 of t minus the maximum of 2S1 of t minus S2 of t and 0. But the maximum of 2S1 of t minus S2 of t and 0 is the payoff of an option to exchange S2 of t for 2S1 of t at time t when 2S1 of t is greater than S2 of t. So now recall that the formula for the price of a European option to exchange asset S for asset Q at time t evaluated at time 0 is the kind of an analog version of the Black-Scholes, that it's the prepaid forward price of asset S times n of d1 minus prepaid forward price of asset Q times n of d2, we need to calculate the prepaid forward prices using the continuously compounded dividend yield on the assets. where D1 is the natural logarithm of the ratio of prepaid forward price of S to the prepaid forward price of Q plus 1/2 sigma squared T, the whole thing divided by sigma square root of T. And D2 is the same thing with a minus sign in front of 1/2 sigma squared times T. So that's the same as D1 minus sigma square root of T. It's an analog of Black-Scholes, but for an option to exchange two assets. With an important observation that sigma that we see in the formula is the square root of sigma s squared plus sigma q squared minus 2 rho sigma s sigma q, where sigma s is the volatility of the continuous compounded rate of return on asset S. So it's the standard deviation of the random rate of return, continuous compounded rate of return, and sigma q is the same for asset Q. And rho is the correlation coefficient of these two random variables. So in this case, S is 2S1 and Q is S2. And we can calculate sigma based on the information given about the standard deviations of the two and the correlation coefficient, which was given as negative 0.4. So there we have the value of sigma. Then we have the prepaid forward prices for the two. And it just so happens that they're equal, so the natural logarithm of 1 is in the formula. So the D1 is just 1/2 sigma square root of T, and the value of sigma is, which is calculated, T is 1, so square root of that is 1. So this is a relatively simple calculation, and then we can find the value of n of D1. And then D2 is minus that, and of course n of D2 is then 1 minus n of D1, because D2 is the opposite of D1. And then the price of the exchange option is therefore 20n of D1 minus 20n of D2, so that comes out to be approximately 2.8712. And based on this, the prepaid forward price of the asset M, the one that we designed for this problem, is the prepaid forward price of 2S1 minus 2.8712. So it's 17.1288. And then X we get from put-call parity as minus that prepaid forward price, which is calculated, plus the present value of 17 plus 1.632. We plug it all in and we end up with 0.6741. And that's answer A. Please remember this is copyrighted material. The problem comes from the Society of Actuaries and belongs to a Society of Actuaries, is reproduced with permission. The solution is mine. Well, good luck in your studies and good luck on the test.